Chapter 1 Matter in Our Surroundings. Introduction to Matter.
Look at our surroundings. There are a large variety of things around us. They are of various shapes, sizes, and are also made up of different materials. Observe your classroom. What are the various things you see? Tables, chairs, chalk sticks, a duster, papers, pens, etc. Are all these made up of the same material? Tables, chairs, dusters, paper are made up of wood. Pens are made up of plastic or metal. Chalks are made of calcium carbonate. All materials are made up of matter. Matter exists in different forms or states.
Anything that occupies space and has mass is called matter. All the above examples of tables, chairs, chalk sticks, duster, pens, etc. occupy space and have mass. Hence, they are made of matter. Apart from this, the food we eat, the water we drink, the air we breathe, the plants and animals, human beings like ourselves are all made of matter. Matter has been classified since olden days in a number of ways. Ancient Indian philosophers classified matter on the basis of the 5 elements: air, earth, fire, water, and space. These elements were called the Panchatattva. According to them, everything, whether living and non-living, was made of these 5 elements. Modern-day scientists have classified matter on the basis of their physical and chemical properties. On the basis of the physical properties, matter can be classified as solids, liquids, and gases. On the basis of the chemical nature, matter is classified as elements, compounds, and mixtures. Let's do a quick check. Physical nature of matter. Evidences for particles in matter. It was believed that matter either could be continuous, as in the case of a block of wood, or particulate, as in the case of chalk, powder, or sand. Let us perform an activity to determine whether matter is continuous or particulate. Take water in a small bowl and dissolve few crystals of sugar into it. The water turns sweet. This is because the crystals of sugar break up into tiny particles that distribute themselves in water. Try another activity. Pour few drops of water on the table. Wipe it off with a cotton cloth. What change do you find in the cotton cloth? The cotton cloth has become wet. The cloth and water are made of tiny particles. Particles of water occupied spaces between the particles of the cloth, making it wet. Size of the particles in matter. Here is an activity to help us estimate the size of the particles in matter. Dissolve a few crystals of potassium permanganate in 100 ml of water. Take out about 10 ml of the solution and add to it 90 ml of water taken in another beaker. Now from this solution, take 10 ml of the solution and add to it 90 ml of water taken in another beaker. In the same manner, prepare few more dilutions. Is the water still colored in the last dilution you have prepared? Yes, although the color of water is pale purple, the color is still visible. This activity shows that there must be millions of tiny particles of potassium permanganate in just one crystal, which keep on dividing into smaller and still smaller particles. This activity proves that matter is made up of tiny particles. These particles keep dividing into smaller particles. Ultimately, a stage is reached when the particles cannot be divided further. The size of a single particle is very difficult to estimate. They are small beyond our imaginations. For instance, a small drop of water or a raindrop consists of as many as 10 raised to 21 particles. Let's do a quick check. Characteristics of particles in matter. Particles of matter have space between them. Let us perform an activity to see that particles in matter have spaces between them. Take 100 milliliters of water in a beaker. Mark the level of water in the beaker with a marker. Add to it 50 grams of sugar. Stir the solution and dissolve the sugar completely. Once all the sugar has dissolved, check the level of the sugar solution. Has the level increased? No. This means that there is no change in the volume of water even after 50 grams of sugar has dissolved in it. This can be explained thus. Particles of water have spaces between them. Particles of sugar occupy the spaces between the particles of water. Hence, there is no change in the volume of water in the beaker. Particles of matter are constantly moving. Let us perform some activities to understand that particles of matter are continuously moving. Place an incense stick in the corner of a room. How close do you have to go to get the smell of the incense stick? One has to go very close to the incense stick to get the smell of the incense stick. Now, light the incense stick in the corner of the room. Wait for some time. Do you get the smell of the incense stick at the distance? Yes, the fragrance of the incense stick has spread in the entire room. This shows that the particles of matter are constantly moving. Now try this activity. Add a crystal of copper sulfate into a glass of hot water and also to another glass containing cold water. Do not stir the solution. Allow crystals to settle at the bottom of the beaker. What do you observe above the crystals of copper sulfate? The clear water above the crystals is slowly becoming blue in color. This is due to diffusion of the copper sulfate crystals in water. The spreading out and mixing of a substance with another due to the movement of particles in the substance is called diffusion. The spreading of the blue color of the copper sulfate crystals in water is due to the movement of copper sulfate crystals as well as water particles in the beaker. This shows that particles of matter are in constant motion and they mix with each other. This intermingling of particles is called diffusion. In which of the beakers is the dissolution of copper sulfate faster? Copper sulfate dissolves faster in the beaker containing hot water. On heating, the particles of water and particles of copper sulfate gain kinetic energy and move faster. Due to faster movements, they mix with each other quickly. This proves that particles of matter possess kinetic energy. As the temperature rises, the kinetic energy of the particles also increases and the particles move faster. Particles of matter diffuse with each other. Diffusion takes place when particles of one substance occupies the space between particles of another substance. Particles of matter attract each other. Let us perform an activity to understand that particles of matter attract each other. Open a water tap. Try breaking the stream of water with your fingers. Is it possible? No, it is not. The particles of water are held by a force of attraction. This force keeps the particles together. Hence, we could not break the stream of water. Here is another activity to estimate the force of attraction in various articles. Take some articles like an iron nail, a rubber band, and a piece of chalk. Try to break them by hammering, stretching, and cutting them respectively. What do you observe? The iron nail does not break on hammering. The rubber band on stretching gets stretched and becomes long, but regains its original shape when left. The chalk piece breaks into many small pieces. This shows that the force of attraction is the strongest among the particles of the iron nail. The force of attraction is the weakest in the chalk piece. We can thus say that the strength of force of attraction varies from one kind of matter to the other. Let's do a quick check. states of matter. On the basis of the physical properties, matter can be classified into three groups: solids, liquids, and gases. The solid state. Let us perform an activity to understand the properties of solids. Collect the following articles and perform the given actions on them: a pen, a book, a needle, a piece of thread, etc. First, sketch the shape of these articles in a notebook by moving a pencil around them. Notice that all these articles have a definite shape with distinct boundaries and a definite volume. Take the articles one at a time. Hammer them, pull them, and drop them. They remain unaffected. Try to compress them by applying pressure on them. Can they be compressed? No. All these are examples of solids.
In solids, the space between the particles is very less, and thus the force of attraction between the particles is strong. Thus, particles in a solid are closely packed. The kinetic energy of the particles is very less, and so solids have an orderly arrangement of the particles. Therefore, solids have a fixed shape and a fixed volume. They maintain their shape even when they are subjected to external force. That is, they are rigid. They also cannot be compressed much. Many solids maintain their shape even when they are subjected to external force. This property of solids is called rigidity. However, there are some solids that change their shape when they are pressed. This means that when an external force is applied, they may change their shape. Solids, like rubber, which changes its shape when an external force is applied, but when that force is removed, it can regain its original shape. This property is called elasticity. Solids, like dough, which can be bent when we apply force on it. But dough cannot regain its original shape when we remove the force. This is called plasticity of solids.
Diffusion takes place in solids but is a very, very slow process. Therefore, people think that diffusion does not take place in solids. For instance, if two metal blocks are bound tightly and kept undisturbed for many years, then we will be able to see that particles from one metal would have diffused into the other. Salt and sugar crystals are very minute. Though their shapes may seem to change in different jars, the shape of the individual crystal does not change and hence they are solids. Sponges can be compressed easily, and yet they are considered solids. This is because they have minute pores which contain trapped air. This air escapes when the sponge is pressed, and hence we are able to compress it. The liquid state.
Let us perform an activity to understand some characteristics of liquids. Take 4 transparent containers of different shapes. Place a 1 feet scale in each of the containers in a slanting position. Take 4 different liquids: milk, honey, water, and kerosene. Pour the liquids along the scale placed into the containers. Do all the liquids flow at the same speed? No, they don't. Honey flows very slowly. Milk flows a little faster than honey. Water flows very easily. Kerosene flows even faster. Honey, being a very viscous liquid, flows very slowly, and kerosene, being less viscous, flows very fast. What shape does each liquid attain in each of the containers? All the liquids take the shape of the container in which they were poured. In liquids, the space between the particles is slightly more than in solids, but still very less. The force of attraction between the particles is strong enough to hold the particles together, but not strong enough to hold the particles in a fixed position. Thus, particles in a liquid are not as closely packed as in solids. The kinetic energy of the particles is more than that of solids. Thus, liquids have a disorderly arrangement of particles compared to solids. Due to these reasons, liquids do not have a fixed shape, but have a fixed volume. They cannot be compressed much. The particles of a liquid can slide over one another. Therefore, liquids take the shape of the container in which they are poured. Liquids show a property called viscosity. More viscous liquids flow slowly, while less viscous liquids flow easily. When they spill on a plane surface, liquids have a tendency to spread and flow in the surrounding areas. This property called fluidity.
Diffusion takes place faster in liquids. It can be clearly seen in the spread of potassium permanganate into water. Also, gases like carbon dioxide and oxygen also diffuse in water, which help the aquatic plants and animals to breathe. The gaseous state.
Let us perform an experiment to understand some characteristics of gases. Take 3 balloons of different shapes. Blow up all the 3 balloons. What do you observe? How are the shapes of the 3 inflated balloons? Air has taken the shape of the balloons in which it was filled. This shows that air does not have a fixed shape of its own. Take an uninflated balloon. Are the inflated balloons heavier or lighter than the uninflated balloons? The inflated balloons are slightly heavier than the uninflated balloons. This is because air has mass. In gases, the particles are much farther apart from one another as compared to solids and liquids. They have a very disorderly arrangement of particles compared to solids and liquids. The force of attraction between the particles is negligible, hence particles of a gas move freely in all directions. Gases thus can spread in all directions and mix or diffuse into other gases. They can also be compressed easily, like in the LPG cylinders used at home and the CNG cylinders used in vehicles. Gases neither have a definite shape nor a definite volume. They take the shape of the container and fill it completely. The particles of a gas have maximum kinetic energy. They move with high speeds in all directions and can exert pressure on the walls of its container.
Let us perform an activity which shows that gases can be compressed while solids and liquids cannot. Take 3 syringes having frictionless pistons. Close their nozzles by inserting them in separate rubber corks. Fill chalk powder in the first syringe and water in the second. Leave the third syringe empty. Air is already present in it. Try to push the pistons of the 3 syringes and observe what happens. The piston of the syringe containing chalk powder, which is a solid, does not move much even after pressure is applied on it. This shows that solids cannot be compressed even when pressure is applied. The piston of the second syringe containing water, a liquid, also does not move much when pressure is applied. This shows that liquids also cannot be compressed when pressure is applied. The piston of the syringe containing air moves down considerably when pressure is applied. This indicates that the volume of the gas inside the syringe is reduced. Thus, on applying pressure, air gets compressed. Diffusion is the fastest in gases. When food is being cooked in a kitchen, we get its smell even at a distance. This is due to the diffusion of the vapors of cooked food with the air. Similarly, when an incense stick is lit, its smell spreads throughout the place in a very short time. This happens due to diffusion of the particles of the vapors of the agarbatti in the air. The fourth and fifth states of matter. Advancements in science and technology has led to the discovery of 2 more states of matter. They are the plasma and the Bose-Einstein condensate, or BEC. Plasma is made of super-energetic and super-excited particles which are in the form of ionized gases. Neon sign bulbs and fluorescent tubes contain plasma in them. Gases get charged or ionized when electric energy passes through them. The color depends on the nature of the gas. The sun and other stars shine because of plasma created in them due to high temperatures. The Bose-Einstein condensate, or BEC, is the fifth state of matter. In 1920, Indian physicist Satyendra Nath Bose made a study regarding the fifth state of matter. Based on his study, Albert Einstein predicted a fifth state of matter called as the Bose-Einstein condensate. Scientists Eric Cornell, Cuttle, and Wieman of the USA received the Nobel Prize in Physics for achieving the Bose-Einstein condensation. The Bose-Einstein condensate, or BEC, is formed by cooling a gas of extremely low density to super low temperatures. Let's do a quick check. Density.
Take a beaker half filled with water. Put a pebble and a plastic spoon in it. Which one would sink and why? The pebble would sink because it is heavier than the plastic spoon. Plastic, corks are substances that will float on water. Substances float or sink in water due to differences in their densities. Let us understand the concept of density. Density is the ratio of mass to volume.
Solids generally have very high densities. The particles in a solid are very close to each other and more particles occupy less space. Hence, they are heavy. Liquids have moderate densities, generally lesser than solids. This is because number of particles in a volume of a liquid is less compared to the number of particles in the same volume of a solid. Gases have very low densities as particles of a gas are far apart from each other. They are hence very, very light. As we have seen, generally, liquids have lower densities than solids. But ice, being a solid, floats on water. Why does this happen? If a certain mass of water converts into ice, its volume increases, thus its density decreases. As the density of ice is less than that of water, it will float on water. This property of water is also called as the anomalous behavior of water. This property of water explains many natural phenomena like icebergs and freezing of lakes. Let's do a quick check. Change in state of matter.
What is change in state of matter? Matter can be transformed from one state to another state by changing temperature or by changing pressure. This transformation is called a change in state. How does matter get transformed from one phase to another? If we bring about a change in the temperature or pressure, there is a change in the spaces between the particles. Change in the force of attraction between the particles and change in the kinetic energy of the particles. Thus, matter is transformed from one phase to another. Let us perform an activity to understand changes in the states of matter. Place a lid on a hot cup of tea. Observe the inner surface of the lid after some time. What do you see? There are tiny droplets of water. From where did these droplets appear? When water vapor from the hot tea comes in contact with the cool surface of the lid, they get converted to droplets of water. What is the state of coconut oil in winter and in summer? Coconut oil solidifies in winter, and in summer, the same oil liquefies. In both these examples, we have seen a change in state.
Effect of change in temperature.
What happens when ice is heated? When ice is heated sufficiently, the heat energy makes the particles of ice gain energy and they vibrate more vigorously. This energy is sufficient enough to overcome the forces of attraction holding them in their fixed positions. The particles then break away from their positions and there is a change in the state from a solid to a liquid. What happens when water is heated? When water is heated, the heat energy makes particles of water gain more energy and move even faster. This energy is sufficient enough to overcome the forces of attraction holding them together. The particles separate out, causing the liquid to change into the gaseous state. What happens when water vapor is cooled? When water vapor is cooled enough, the particles of vapor lose energy. They move closer until they start being attracted to each other. This causes vapor to change to water.
On further cooling, particles of water lose more energy and get still closer to each other. Gradually, water changes to ice. The Kelvin scale, the SI unit of temperature. The common unit of measuring temperature is degrees Celsius. We use this unit for measuring temperature in our daily life. It is denoted as degree C. The other scale used for measuring temperature is the Kelvin scale, invented by Lord William Kelvin. It is the SI unit of measuring temperature and is denoted by the alphabet K. Please note that we do not use the degree sign in the Kelvin scale. All temperatures on this scale are positive. The relation between the two scales of temperature is temperature on Kelvin scale is equal to temperature on the Celsius scale plus 273. Thus, if the melting point of ice is 0 degrees Celsius, then in the Kelvin scale it will be 273 Kelvin. Similarly, if the boiling point of water is 100 degrees Celsius, then in the Kelvin scale it will be 100 plus 273 is equal to 373 Kelvin. The temperature 0 Kelvin or minus 273 degrees Celsius is called absolute zero.
Melting and boiling points. We know that matter exists in 3 different states: solid, liquid, and gas. We also know that the same matter can exist in all 3 states under different temperatures. Can you give an example for this? The most familiar example is given by water. Water can exist in all the 3 states. When converted into ice, water goes into solid state, and when converted into vapor, it goes into the gaseous state. On heating, ice changes into water. This process by which a substance changes from solid state to liquid state on heating is called melting. Similarly, water on heating changes to water vapor. This process by which a substance changes from liquid state to gaseous state on heating is called vaporization. Latent heat of fusion and vaporization. Take some small pieces of ice in a beaker. Suspend a thermometer in the beaker to note the temperature of ice in the beaker. It is essential that the thermometer bulb should be fully immersed in ice. The initial temperature of ice, which would be 0 degrees Celsius, is noted. Place the beaker above a spirit lamp and start heating the ice gently and uniformly. Note down the temperature every minute from the thermometer. Ice melts gradually. We should keep on stirring the mixture of ice and water on the burner thoroughly. We find that the temperature of melting ice remains constant at 0 degrees Celsius as long as there remains any solid ice. This temperature at which a solid starts changing into liquid state is called its melting point. This process, in which a solid changes to liquid at its melting point is called melting or fusion. Now, the whole of the ice has melted and changed into water. If we continue the heating process, the temperature of water starts rising steadily. Note the temperature of water every minute. We will see that the temperature of water rises gradually till it reaches 100 degrees Celsius. Thereafter, it becomes constant. This temperature at which a liquid starts changing into gaseous state is called its boiling point. This process in which a liquid changes to gas at its boiling point is called vaporization. At this temperature, water begins to boil and gets converted into steam. During this change of state from water to steam, the temperature remains constant till all the water gets converted into steam. Whatsoever heat is supplied to the water, the heat is utilized in changing the state of water to water vapor. We have seen that when there is a change of state, the substance absorbs heat, but its temperature doesn't increase. All the heat energy is used to break the bonds and convert solid into liquid or liquid into gas. All the heat is used to overcome the force of attraction between the molecules of the substance. This heat is called latent heat. The latent heat absorbed during change of state from solid to liquid is called latent heat of fusion. Hence, latent heat of fusion of a substance is defined as the quantity of heat absorbed by unit mass of substance to change it completely from solid to liquid state at the melting point. If the state of the substance is changed from liquid to solid, heat is liberated. Similarly, the heat absorbed during change of state from liquid to gas is called latent heat of vaporization. Latent heat of vaporization of a substance is defined as the quantity of heat absorbed by unit mass of a substance to change it completely from liquid to gaseous state at its boiling point. During change of state from gaseous to liquid, latent heat is liberated. Different substances have different melting points. Similarly, their boiling points are also different. Melting and boiling points of a substance are the unique characteristics of that substance. The reverse process of change from liquid to solid is called freezing. The process in which a liquid changes to solid state at some fixed temperature by liberating heat is called freezing.
Sublimation. There are some substances which change from the solid state to the gaseous state and vice versa without changing into the liquid state.
The process in which a solid directly changes into the gaseous or vapor state on heating and directly changes back to solid state on cooling without changing into the liquid state is called sublimation. Substances like ammonium chloride, naphthalene, and camphor exhibit the property of sublimation. We often keep scented naphthalene balls in toilets so that when they sublime, they would release fragrance in the air. Let us perform an activity. Take an evaporating dish. Put some ammonium chloride in it. Place the evaporating dish over wire gauze kept on a tripod stand. Take a glass funnel and plug the opening in the stem of the funnel with cotton. Invert this glass funnel over the mouth of the evaporating dish. Heat the evaporating dish. Soon you will observe that vapors are formed. Stop heating the evaporating dish. When the evaporating dish cools, remove the glass funnel and see the inner part of the funnel. We see a white deposit on the inner wall of the glass funnel near the base of the stem. With the help of a spatula, scrape out this white deposit into a watch glass. What is this white powder? Let us find out. This white powder is ammonium chloride. When ammonium chloride was heated, it directly changed into ammonium chloride vapors without getting converted into the liquid state. On cooling, the ammonium chloride vapors changed back to solid ammonium chloride.
Effect of change of pressure. Can we liquefy oxygen gas? Yes. By applying pressure and reducing temperature, we can liquefy oxygen gas. The molecules of the gas remain the same. They only come closer to form a liquid. Gases can be liquefied by applying pressure and lowering temperature. When a high pressure is applied to a gas, it gets compressed, and if the temperature is lowered, the gas is liquefied. Let us understand this. In a gaseous substance, there is a lot of space between the particles. If pressure is applied, the particles of the gas come closer and the gas is compressed. When a gas is compressed, heat is produced due to compression. So while applying pressure, it is necessary to decrease the temperature in order to take away the heat produced during compression. Liquefied and solidified gases are used in a variety of ways. Liquid nitrogen and solid carbon dioxide are used for storage and preservation of food. Let's do a quick check. Let's do a quick check. Let's do a quick check. Evaporation.
Before an injection, when the nurse applies spirit at that site, how does one feel? That area feels cold as the spirit evaporates from the skin. This happens because when the spirit changes from liquid state to the vapor state, it absorbs heat energy from the skin. The skin thus loses heat and gets cooled. Why do we pour very hot tea in a saucer? When tea is poured in a saucer, it cools faster. Evaporation is a surface phenomenon. The particles of tea on the surface absorb heat for vaporization from the remaining particles of tea and evaporate. The tea thus loses heat and cools faster. How does the water kept in an earthen pot become cool even in summer? The earthen pot has small pores in its walls. Some of the water continuously seeps out from these pores. This water evaporates and absorbs heat for vaporization from the remaining water. Thus, the remaining water loses heat and gets cooled. The process of a liquid changing into vapor or a gas below its boiling point is called evaporation. What happens during evaporation? Evaporation is a surface phenomenon. Particles of the liquid on the surface gain energy to overcome the forces of attraction present in the liquid and change into the vapor state, causing evaporation.
Factors affecting evaporation.
Surface area. Since evaporation is a surface phenomenon, the rate of evaporation increases on increasing the surface area of the liquid. Temperature. The rate of evaporation increases on increasing the temperature. When a liquid is heated, more particles of the liquid get enough kinetic energy to change into the vapor state. This increases the rate of evaporation. Humidity in the air. Humidity is the amount of water vapor in the air. When the humidity in the air is more, the evaporation is slow. And when the humidity in the air is less, the evaporation is fast. Speed of wind. When the speed of wind increases, the particles of water vapor move away with the wind, thus decreasing the amount of water vapor in the surroundings. Thus, the rate of evaporation increases.
Cooling due to evaporation.
How does evaporation cause cooling? When evaporation occurs, the particles of the liquid absorb heat from the surroundings. Thus, the surroundings lose heat and get cooled. Why does a desert cooler cool better on a hot, dry day? On a hot day, due to the increase in temperature, the rate of evaporation of water is more. Also, the dryness of the air, that is, decrease in humidity of the air, increases the rate of evaporation. Therefore, a desert cooler cools better on a hot, dry day. Why should we wear cotton clothes in summer? In summer, we perspire more. Cotton, being a good absorber of water, helps in absorbing the sweat and exposes it to the atmosphere for evaporation. When sweat evaporates from our body, it takes heat from our body. Thus, our body loses heat and gets cooled. Condensation. The process in which a gas, on cooling, turns into a liquid at a specific temperature is called condensation or liquefaction. During condensation, the particles of the gas lose kinetic energy and come closer until they start being attracted to each other and form a liquid. We know that formation of clouds is due to condensation of water vapor from the Earth's surface. The heat removed from the surface through evaporation is released again in the atmosphere by the formation of clouds. This process cools the Earth's climate. We find dewdrops, especially in the early morning, on the leaves. Why? There is water vapor in the air around us. When this water vapor comes in contact with the cool surface of the leaves, it condenses to form dewdrops.
Let's do a quick check.